So thank you very much for having us. We've been looking forward to this. We have I'll just move on here. The agenda for today is that we'll very briefly present who we are. I'm not sure if many of you have heard of us before. We also want to present to you an overview of the FAIR principles, what FAIR is and how to be fair, and with research data management. We want to share with you the national strategy for data management, which is basically following how FAIR research data management is being implemented at the Danish universities. We'll look briefly at research funding bodies and their requirements for FAIR, particularly looking at the Horizon Europe data management plan, and then we'll have some time for questions and answers. So I'll just quickly present ourselves. We're from DIKE, Danish E-Infrastructure Consortium, and we have the task of developing and coordinating collaboration on digital research infrastructure for the universities covered by the University Act. We have a board that consists of leadership from all 8 Danish universities, and we have 3 main areas that we work with. HPC, high performance computing. We have a research network, and we have data management, which is where René and I are from. So with that, I will move on to the next slide and give the floor to my colleague René, who will go on from here.
Hello, everybody. My name is René Belso from DIKE. I'm here to talk to you about FAIR data and data management and FAIR principles. I will begin at a very aggregated high level, explaining what it's really about. It's really about adapting research to the huge potential that information technology offers us. That is in terms of compute power and in terms of data storage and linking the two together and analyzing data through simulation, modeling, and data analytics, artificial intelligence, and all of the possibilities that lies therein. For this to happen and to be possible, data has to be very well organized and very well understood in its context of the research agenda at hand. So it basically consists of 3 major driving forces or elements, I might say. One is it's a matter of a cultural change. It's a matter of understanding the scientific empirical foundation in a different way. It has to do with digital objects and the way computers can work with these objects. So it's basically a change where one has to ask oneself, what does this change actually mean for my research agenda? What is the potential? What are the different things guiding my research under those circumstances? Then it has to do with training and with competences. There are some new things that has to be understood. There is a different kind of structural necessity in understanding the infrastructure and the tools at hand. And then there is the actual instruments and building them for the specific research agenda. That could be domain-specific tools, it can be domain-specific research infrastructure, or it can be more generic, all-purpose kind of things like databases, network capacity, and so forth. So those are the elements. And I think it's most important to understand in terms of the raison d'etre, the why, there is a push and a pull element here. Now, in terms of research funding, you would ask, so why does this concern my funding? Well, it does because it concerns the preconditions that release the funding for some funding agencies. And it has to be said, more and more funding agencies do actually demand data management plans and a justification of how data is responsibly handled and so forth. So this is what we call the push element of the FAIR data agenda, in meaning that the research is being pushed to do something which maybe they otherwise would not do, get their data ordered. But obviously, any advanced researcher or any researcher indeed understands that, of course, the data has to be well ordered. Of course, there has to be a real thought-out plan for this, because this is what my research depends on. Some researchers understand this much better than others. There is actually a huge difference in the approach to this. You might even say that for some research areas, the push is much stronger than the pull. But closely related to what the people here are dealing with, I would say fields like bioinformatics, chemistry that overlaps into medical research and so on, they actually really understand how to organize their data and how to use computing. The second thing about the training is a very different thing. Competences is very complicated. It has a kind of a level element. It can be on a very low level, like let's say an educated librarian, or it can be at the postgraduate level, or it can actually be colleagues that are absorbed into the team, data analyst specialists that are actually peers and who have their names on the publications and so forth. Then there is, of course, the place in the research phase, which part are we talking about, which kind of infrastructure, which kind of tools, and so on. Now I will introduce the actual FAIR principles. So next slide, please, Sandra. They are, in a way, very simple, at the same time as very complex. So in this simple way, the FAIR principles, F-A-I-R, it's called FAIR because each of these letters stands for a specific part of the data handling, and that is respectively the findability is the F, and the accessibility of the data is the A, and interoperability, the ability to reuse it in other contexts, is the I, and reusability is the R. Sandra, you're a bit too fast here. Stay here. So the thing is that many of these, each of these letters consists of a number of initiatives and preconditions for it to be really valid. So what is actually findability? Obviously, data that cannot be found is not data because it just doesn't exist if it cannot be found. But of course, it can be more or less easily found. It could be on your USB stick in your pocket, then it's findable. Or it can be traced by a search on Google, and the computer can access it via the hits that come from Google in an automated way. That is more findable, more acceptable, because it can be findable without being accessible. Because you found something doesn't mean you can access it. And to the findability, there are these letters, F1, F2, F3, F4. I will not go into that, but it has to do with specific elements like persistent identifiers, metadata, and the linkage, and so forth. And with the accessibility, it has to do with using language which is generic within the research community. So, for example, to many, it might come as a surprise that temperature is not just temperature. So for geologists and climate researchers, temperature is very undefined for many. It actually, for some, it means temperature on the surface of the ground. For others, it means temperature 1 meter above the ground at the atmospheric pressure of 1 atmosphere. So there are different ways of having this language of all this metadata, which has to be in order. So next slide, Sandra. And then we move on to, so next, so the interoperability is, of course, a lot to do with these language definitions are cleared within the community and preferably with other communities, so that everybody agrees on how to understand the concept of temperature, for example, or pressure, or whatever it is, metadata one works with. These standards are more complicated to reach than actually you would think. It has to do with community consensus building and so forth. The reusability aspect of it, of course, has to do with openness and with giving enough information such that this data is actually indexed and can be found in various repositories, that the repositories advertise their data and so forth. And of course, again, it has to be reusable, not just within a specific small group, preferably within a whole research domain community, but also across communities. And within this handling of all these FAIR principles, there are a lot of sub-concepts which are part of this agenda, and it has to do with metadata for machines, FAIR implementation points, FAIR data points. There is the identifier discussion, how to make persistent identifiers. There is the FAIR digital object understanding of data, which is archived. And then there is actually the very important thing called the verification process, or the process which one goes through in a workflow such to make data fair. There are a number of steps. If you go to the next slide, Sandra. Sorry, I forgot this one. There are some few things that has to be very clear, and that is especially important to some specific areas which work with sensitive data. FAIR data, besides the push and the pull I told you about, I mean, are we doing it because we have to, or are we doing it because it's good for our research agenda? That being one thing. The other thing is that it's all about having your data ready for a computerized, machine accessible future. So that means that your databases and so on should be designed in a way where people outside with their computers can have access to your data. And here comes the very important thing. FAIR data has nothing to do with open data. So thinking that, well, we work with very sensitive data, GDPR sensitive data, that does not mean your data shouldn't be findable, accessible, interoperable, or reusable. Not at all. It just means that it's just a select few who gets access to it through some various security measures. So those things are a common misunderstanding. It's also that has to be understood that a lot of data is not worth making fair. So if you, for example, have a data stream from a measurement instrument, then this data stream in and of itself might not be worth saving or archiving, but some of the data in it might well be. So that is a matter of choosing what data to make fair and what not to make fair. Then there is the phenomenon of degrees of fairness. So something can be more or less findable, it can be more or less reusable, and so forth. And then, of course, the real key to this is the craft. I would say it's really it's a science and a craft to work with how to manipulate and manage your data and your metadata and your infrastructure in such a way that you optimize it for your specific research agenda. And that we call the verification process. And that's the next slide. We come into that. And this process consists of a number of steps. This graph and this approach, it has a number of different presentations. You can Google it and you will find another representation which maybe only has 5 steps or maybe 8. But our one here has 7. And it all starts with asking yourself, why am I doing this? I mean, if you're only doing this such that you can say you're doing it, such that you can get your European Commission grant, then that's kind of one level of ambition. But if you're doing it because your data streams and the data you're working with in your simulation models are so complicated that you cannot progress your research agenda unless you make order in this data in a much higher and enriched way, then it's a very different thing. The second thing is that you have to understand the data you're working with. It might be a trivial question, but we do meet very often. Researchers would say, well, these are my fields and they are in these records, and these records, they are in these files. But then when we look into it, it kind of turns out to be somewhat of a mess, and the metadata is a bit unclear. It's a bit unclear what the fields are, and so forth. Then the third one, actually turn next slide. Yeah, this was the third. Yeah, that is to work with the metadata, and this is actually it suddenly becomes like a linguistic art. So this back to the temperature again. So when you say we have a field here called temperature or air pressure, then you actually have a reference to that somewhere else, which clearly defines what you mean by temperature or what you mean by pressure. So that the vocabulary is controlled, and you have a discipline around your metadata, which is at a very high level. The next one, Sandra, 4, yeah. And this is about taking choices. So once you really understand your data, then you have to make infrastructure choices, like which database software are we actually going to use for this? Which API application interface are we going to use? and which hardware do we need? Should it be super advanced, or can it be just a simple server? How do we do this? Maybe we put the data in a cloud infrastructure that's much more secure and cheap, or maybe we actually don't do it at all, but we go with our British colleagues and we put our data in their database, because that actually is much easier, and so on. All depending on what is possible, what you feel secure, comfortable with, and what is scientifically feasible. Next slide, Sandra. And then there is the referencing the data. So once it is there in some kind of infrastructure, typically we would say it's a repository. It has to be found via a persistent identifier, and this identifier is also what you would put in your citation in your article when you're referring to such and such laboratory tests and such analysis on this data. You would give the software a persistent identifier such that people can download the software and download the data and try to do the experiments themselves and do the analysis themselves. So that is also a quite important step. The sixth here is this is actually to do with the kind of trustworthiness and the quality of your hosting. So if you, for example, go with a server running in a cloud infrastructure in a virtual image somewhere, that might be deemed very insecure and very risky. But it could be the opposite. It could also be fine. But there is, within the repository understanding, there is something called certification and various levels of quality. And this has to be decided which way you would like to go with that. And this last one here is the overall assessment before you actually go through the circle again and again and again. And this is an iterative verification process. So that's basically it. That's the FAIR principles. And then, of course, working with this demands a lot of competence and knowledge. Some scientific areas and research teams that are very well organized and have a certain critical mass of people, they choose to hire data specialists, computer specialists, high-level support people who work together with the researchers as part of the research team as equal peers. And this competence level is actually quite complicated. So if you move to the next one, yeah, Sandra's warning me here, I'm running out of time. Fine. I just say that it has to do with more than politics. So it could be that you're working on this by yourself. This is the axis, the horizontal, no, the vertical one. It could be that you're working by yourself with this. It could also be that you're part of a team or an institute who has a policy. It could also be that you're part of a European infrastructure which has a more international take on this. It could be that you're one step in the research phase working with the FAIR data. It could also be in another. It could be your challenge is politics or economy. It could be that it's sociology and change in mentality, or it could be technology. I think the next one is my last slide. If I don't, yeah. This one is maybe too complicated to go into now. It has to do with the changing landscape. So many research teams which are in the beginning on the x-axis and up the y-axis, they are actually very good at this. They are the big European ESFRIs, we call them, on the European Roadmap for Research Infrastructure. They are very well organized, they're international, and they have specific departments doing nothing else but data management and computing. Then there are on the x-axis to the right, there are the smaller groups and the individuals which maybe just choose to use commercial software, which they get, Google, Microsoft, whatever. And then you have to work out where are we in this and where can we seek support from our support departments. That could be university infrastructure support and so forth. So that's about it. Then the next slide is opening for you, Sandra. I think try to go to the next. Yes, this is then when we have, no, not that, but yeah. We, the Danish Ministry of Research and Technology asked our organization to host a dialogue with the universities leading to a national data management strategy, a national strategy for FAIR research data management, it's called. And that is published some years ago, and now it's being implemented at the 8 Danish universities. And Sandra will tell you much more about that. Thank you.
Thank you, René. So as René said, I'll just tell you a little bit more about the National Strategy for Data Management based on the FAIR principles. So this is also basically what we know about what is being implemented at the Danish universities in terms of FAIR. So the whole basis of the national strategy is basically on the based on EU legislation, the Open Data Directive, which from 2019, which states that all member states shall support the availability of research data by adopting national policies. And that it should be following the principle of open by default and compatible with the FAIR principles. It's also very important to note that here in this it says as open as possible, as closed as necessary. As René was saying, FAIR does not necessarily mean that everything is open access. So a little bit about the history. In 2019, the Danish Ministry of Education and Research, they published a strategy for national collaboration on digital research and infrastructure. And this was a very comprehensive strategy which encompassed all of the areas that DIKE works with. But in terms of data management, FAIR data management and a strategy for FAIR data management was explicitly mentioned. In 2021, a strategy for data management based on the FAIR principles was released by DIKE's data management team, where they listed the areas that were important, the action areas that would be important for a strategy to work with in terms of implementing or following FAIR data management in Denmark. In 2021, a reference group was established by the Danish Ministry of Education and Research with the task of monitoring the implementation of the FAIR strategy at Danish universities and other public research institutions. And it was important for the ministry that this was not called a steering committee or a steering group, but actually a reference group. So basically the strategy is following what is going on, but it's not implementation as such. The reference group, they also established 5 working groups that dealt with issues related to FAIR in the areas of policies, infrastructure, financing, security, and competences. Some of the things that René mentioned earlier in terms of what is important in order to be able to implement the FAIR principles. In 2021, in 2022, the working groups and the reference groups, they delivered a report to the ministry on how the work was going and what was going on within these different areas. And at the end of 2022, the Danish ministry extended the mandate of the work for 2 more years, and we're now in the second mandated period. So the work is organized with a reference group and 6 working groups. The reference group consists of university management from all 8 Danish universities and from leadership from research funding agencies and management from the Danish Ministry of Education and Research. The working groups, they consist of researchers, data management, data managers, IT developers, and research support staff from the universities. This year we have 6 groups, and an extra group which is looking at the value of data. But we have these 6 groups that look at policies, the infrastructure, the financial backing, competences and knowledge, security, and the value of data. I won't go methodically through these action areas. It's just to give you an idea of how the work is organized. So basically, the working groups will all create an action plan where they work with these different areas, and they'll look at how the universities in Denmark are following these principles. So in the working group for policies, they're looking at how different academic disciplines work with the implementation of the principles. They're looking at policies and that support efforts to support access to and reuse of research data, and they look at policies on persistent identifiers. They're also looking at best practices. And we have the working group B on establishing FAIR infrastructure. And this group is looking at long-term preservation, which means more than 10 years, and how to ensure collaboration between research institutions like and the Danish National Archives. In working group C, FAIR financial plans, in this group we have we have a few foundations who are participating. Here we're looking at what possible requirements could the foundations in Denmark, both public and private, do in order to support FAIR research data management. So we are, for instance, looking at, well, how does the Horizon Europe program do it? Could the foundations look more into requiring a data management plan? And what expenses could foundations be expected to contribute to data management in their budgets? We have a working group D that are working with FAIR competences and knowledge. This is yeah, there's a lot on the screen to take in, but basically without the support at the universities, it's very difficult to implement FAIR data management. And so this group is really specifically looking at how is it structured at the universities, what competence profiles are there, could there be interest in national coordination of FAIR in terms of data management courses, or at looking at a interest in a data management competence center, for instance, and also looking at incentive structures, because of course it requires a little bit of work, but if there was more incentive or merit recognition, then obviously it would be more, and there might be more uptake of FAIR data management practice. We have working group E, who are looking at security, and they are looking at the requirements for security in terms of storage and sharing of data. They're looking also at how researchers and different research groups see their data themselves and what might be sensitive in terms of dual use. And lastly, we have the working group F, which is looking at the value of data. And this is very important because, of course, it's not all research data that can be stored forever. Here we have there has to be some sort of policy at the universities in terms of what should be stored, what should not be stored, and so on. So these action areas, they address the current status of FAIR data management in Denmark. That means that we have not answered these questions yet in Denmark. And implementation of FAIR research data management in Denmark is not widespread yet. And the strategy is basically, it is a response to the Open Data Directive. This is the way that we are implementing policy in Denmark, by following the university's progress on FAIR research data management. I've put some links in here, and I'm sure you'll get the slides afterwards, so you can read and follow the work that has been done last year and the work that will be done in 2024. So onto research funding bodies and FAIR requirements. So the Horizon Europe program, they have required their applicants to use their template when making a data management plan. And I'll just see if I am able to go in here. And I just wanted to share this with you very quickly. This is the template for Horizon Europe's data management plan. And here you can see that they have a number of questions regarding FAIR data. So it's all about how do you make your data findable, including provisions for metadata, a lot of questions here, making data accessible, making data interoperable, and increasing data reuse. So it really forces the applicants here to think about how they make their data fair. And applicants have asked before, will I be rejected if my data is not fair enough? And I don't think that that is the purpose of this. It is more in order to make people start thinking about making their data fair. Of course, there are challenges with this. Research communities create FAIR together. So where the data is published is something that research communities need to agree on. What standards to use, what data formats, and what metadata templates and vocabularies. And some communities have not come so far yet, and then it is very difficult to get started with FAIR. So we do have a few public and private funding bodies participating in the National FAIR Strategy. We have Danmarks Grundforskningsfond, Novo Nordisk Fonden, Innovationsfonden, and Danmarks Frie Forskningsfond. And all of these foundations are very clear on the importance of FAIR, but it's not to say that it's still quite a process in terms of implementing any kind of requirements to applicants. However, all public and private foundations in Denmark recommend their applicants to follow the university policies, and all the universities in Denmark have a data management policy, which includes FAIR to some extent. We are on our way, but we're not, quite there yet. So to sum up the intent of the FAIR principles, I'd just like to quote an abstract of the article that defined the FAIR principles in 2016. And that is that there is an urgent need to improve the infrastructure supporting the reuse of scholarly data. Distinct from peer initiatives that focus on the human scholar, the FAIR principles put specific emphasis on enhancing the ability of machines to automatically find and use the data, in addition to supporting its reuse by individuals. So with that, I would like to say thank you for having us. I actually have also created a little Menti just because we thought that it would be nice to have a little bit of feedback from you. So if you want to, you are more than welcome to give us a little bit of feedback here. And otherwise, we're happy to take questions.
Okay, thank you. Thank you a lot to both of you. And you can raise questions in the chat, or you can also just raise your hand, and then we will give the word to you. I can start. You were mentioned that if you're not having the FAIR data description in your application, you will not be rejected. But in the future, will it be an area for competition between the research groups? First of all, I'm thinking in Denmark, but also when you apply for the bigger grants in, for instance, the Horizon Europe program, will that be something that will be considered as an evaluation part, as it could be the research area or how strong the research groups are and so on? Will it be a significant part of the evaluation in the future, do you think?
Well, I think the fact that they've made it a part of the template itself says that they think it's very important, but the not being in that process, then we don't know how they evaluate this. But recently, I was at a DTU Research Data Management Day where a lot of the applicants were very, very worried about this as well. And they were told that it was not something that they needed to be worried about. It was just not something that they needed to be able to fill in. It was something that they needed to have considered the various parts of FAIR in the application. In the future, it's yeah.
But the slide that René showed with the graph there, where the big consortiums, they were already in place with the FAIR principles, and then there was a lot of the others on the x-axis that was not dealing with that in the same part. But so it will favor in some kind the bigger consortiums in the future, because the way we grant in the DDEA, we have around 120-130 grants in total. It's just small grants for an individual person for a smaller projects. So for him or her to deal with this, how will that be?
I think there's a few takes on this. The first thing is so how is it evaluated? I would say as information technology and digital data becomes an everyday thing within any scientific discipline, then when you do write an application grant, you have to argue your research justification, and you have to explain what you're doing. And if you show that you have a mess in your data, that ultimately weakens your application, just like it would be weakened by many other aspects that you don't know about your own theories, or you have weaknesses somewhere else. It damages your potential. But that said, there are, of course, various areas of research where it's more or less important how you actually take the data into the digital world. I mean, to which extent are you actually making your data accessible for computers, modeling and simulation, such that, I mean, for example, if you go into a modern day weather chart, you will see data from at least 300 different sources, maybe thousands of different sources that are aggregated into rain charge, wind velocity, blah, blah, blah. And of course, that would only work if all this data is super strictly organized. So in this way, yes, of course it matters, and it makes a huge difference. As for the graph you spoke about, I think that the thing is there that many universities see that they need to up their investments in research support. Normal IT departments are overly concerned with budgetary software. They look into how to pay their staff and HR and all kinds of things which are IT but not research relevant. More and more universities understand this, and they begin to make dedicated support departments which have high-level compute consultants and data managers and data stewards, which help. Obviously, some universities are more progressed than others. In Denmark, we're not super advanced in this. Go to Cambridge or MIT, it will be a complete different ball game. Oh, and of course the commercial sector. Yes, you're right. It's moving in. It's very tempting to use Google Docs. It's very efficient. It's very good, and it's very reliable. It has a few security issues, obviously. There's also some vendor login and some dual use kind of considerations which pollutes the attractiveness. On the other hand, you see well-organized research groups that organize themselves on a global scale within, I mean, just look at the European roadmap, ESFRI roadmap. There you will see researchers who really organize themselves well and make good infrastructure and take care of their data.
Okay. Anyone who has a question? Otherwise, I have another one. So will that be a part of the budget in the future? Because now you're saying that the universities will have to strengthen their game or their departments where there will be help to the researchers. Will that, of course, that costs money. So will we see an increase in the running cost for when you apply for a grant, then the universities come back and say, well, you need also to take care of the FAIR principle, and that will add on to the running cost. Will that be something that we are looking into? Because I know it's different what you can get from the running cost.
Yeah, sure.
Yeah.
The overheads, they already pay for the basic IT, right? So you don't pay extra for your high capacity networking. You also don't pay extra for, let's say, virtual imaging and so on, compute resources. But of course, as it gets up to a point, you will have to add that as a separate expense beyond the normal. And you can go to the public and the private funding agencies, and you can add this to your research application already today, and you can argue your case that, well, I need an especially powerful compute infrastructure. Therefore, this is such part of my budget. That's already seen today.
I think it's also fair to say that in the future, yes, there will be increased budgets on FAIR research data management. There will be a need for more data stewards, and it will also be possibly also more funding from the funding bodies who decide to put more money into it.
You could, of course, have the suspicion from the point of view of a researcher or research team. You could say, is this something that is going to dilute my research agenda because they're taking a slice of my funding for something that actually I don't really want? That could be a concern for some. And sure, that's a concern, just like a part of your funding goes to running a library at the university. You might not think it's worthwhile having this library. This is a concern that is valid. On the other hand, much of this infrastructure is domain specific, and you will have to fund it through your research grant. Unless it's trivial generic infrastructure, you will expect that to be delivered by your university and have a right to complain when it's not. That might not lead to anything, though.
And then you mentioned something about that. What is the status in you mentioned, both of you, the status in Denmark as compared to our colleagues in Europe, US, Asia, India, Australia, Africa?
Yeah, in Europe, it's very different. I mean, the Netherlands are often seen as the country who are very, very far ahead of the rest of us in terms of FAIR research data management. Also, they have funding bodies who require their applicants to be much more on board with FAIR, and they have the infrastructure in place and so on. So Denmark is in Europe, at least, not at the forefront yet.
And it requires supercomputers around your universities to storage all the data, or are they in place, or how is it?
That depends on your research agenda. I mean, it depends on what you're doing. If you are working with vast amounts of data, this data might be hosted somewhere else, and you just want access to it. And then you have it's a kind of an accessibility issue or a policy issue. But on the other hand, you might be working with correlating data from different sources, and you need to put that into a computer model, and therefore, yes, then you have to deal with computer centers. Yeah, sure. I mean, research in, for example, using artificial intelligence to look for causes of Alzheimer, that's huge amounts of compute resources and data resources.
Okay, good. The floor is still open for questions. Anyone who would like to raise a question?
Maybe we could ask you as well, the participants here, if they have any knowledge or any experience with FAIR in general.
Fine question. Yeah. Anyone like to answer that question if you have any experiences with FAIR, the principle, or in practice?
I can say that I haven't really heard of it before. Hi, my name is Hannah, by the way. I haven't really heard of FAIR before, and I would also say that it sounds super relevant and as something that we should definitely have as part of how we plan our studies, and something that I will definitely look into now that you introduced me to it.
And Hannah, you are working in a cross between a life science company, right, and university hospital. Is that the same? How are they dealing with these data in the life science industry, and will that be a problem when sharing data in another setting than across sectors?
I have not. I don't know. I'm working with funding from life science, from Zealand Pharma, but I'm not working with them directly. So I'm not spending my time there. But it's definitely a good question of how that would work and how much of the data that are then worth putting into this kind of structure if it's never going to be shown to anybody.
René, Sandra, do you know anything about that? Is that a different game when it comes to the life science industry about how they are handling this principle? Because they have, I know they have a really strict.
I would say life science is one of those areas that I mean, they already know all about this. I mean, they are heavily dependent on having a good handle on their data. And they are very much computerized.
And I mean, we met, or we spoke to a researcher group from Copenhagen University last year, who were looking specifically at data of newborn babies and how the further developments, and they had created a consortium of researchers within Europe where they shared the data with each other in a very controlled environment. So there was a lot of access protocols to the data, but they were able to share the data with each other and work on this data together. So there is definitely controlled environments for people working with sensitive data.
Being a devil's advocate about the data, because I think a lot of the researchers, at least what I've heard of, is struggling with the GDPR rules and not allowed to share anything. And now there's a new ball game with the FAIR principle, and say, well, how come it should be so difficult to work with my research? That's what I'm here for. So what is the answer to this?
So security and GDPR is a common misplaced excuse for not making your data well ordered. It's no excuse. I mean, even if it's super top secret, you still need to have a very, very strict discipline with your data. Except the only difference is it's not just for everybody, it's only for a few. So these issues are completely separate in my view.
Okay. Yeah, fair point. Good. If anyone has the last question, now it's time.
I put in the chat an interesting conference on exactly this issue, which is run by Medical Science. It's in the Netherlands. It's quite interesting what they're discussing. You could look at the program and see the subjects, and it'll give you an idea of what's at stake here within medicine.
Good. Then I will just share my screen just a second. Just to highlight that we still have 2 open calls for scholarships. And now we have someone from the data science environment. Then I can encourage you also to look into the DDSA, DDEA. The DDSA is the Danish Data Science Academy, we have 5 PhD scholarships posted in collaboration with them, and the main PI must be from the data science environment. So if you know someone who could be of interested in these kind of scholarships, then please make them aware of that. And then we also have a call together with our another sister academy, the Danish Cardiovascular Academy. So with these words, I will end the session, and thanks all for being here, and have a good day. And I hope to see you again the 6th of December to the 6th webinar coming up. Okay.
Thanks for having us. Bye.
Thanks
Bye.
for having us. Bye.